Hello boys and girls, a very good evening and welcome to this live score booster for your upcoming SBI Clerk's preliminary exam brought to you by TalentSprint. I hope all of you are in good health and your preparation for this highly competitive SBI Clerk's preliminary exam is in high gear. And I also hope that these score boosters brought to you by TalentSprint are adding value to your preparation. However, the one point that I would like to mention is attending these sessions alone is not going to help you achieve your dream job, right? There is a lot more stuff other than these sessions that you need to do in terms of learning various concepts, techniques, shortcuts, and practicing as much as possible so that you can maximize your chance of selection, right? So my sincere advice to all of you is not to depend just on these score boosters, but then do a whole lot of preparation otherwise, right? And it's high time that you have your own preparation plan and proceed with the proper strategy so that you can complete your preparation by the time you approach the examination, right? See, having no plan is a very difficult problem and it can, land you in a very difficult situation. So have your own preparation strategy, right? Make a study plan, something like a 30-day or a 45-day study plan, assuming that the exam happens in the mid of March, or let's say towards the end of March. So you have about 30 days for the examination, right? So keeping these 30 days in mind, you should now have a 30-day or a 45-day plan and proceed with that approach and stick to that plan so that you can complete everything in time and don't have that last minute panic. All right, so just make sure that while you're preparing, you also have a strategy for your preparation, right? Preparation alone is not going to help you. You got to back it up with a proper strategy. Now the session today is basically on a very interesting technique. In fact, one of my favorite techniques from Simplifications. While it is a favorite, personal favorite, I would not recommend you I would not recommend this to be applied in every question that you solve in Simplifications, right? Because it actually is very interesting, but also can be time consuming at times, right? You should know where to apply. And not just with this technique, even otherwise, any shortcut formula that you learn or any technique that you learn, I think more than the technique, the application is important. You should know where to apply, right? In which scenario or in which situation will this technique be helpful, right? Every shortcut is not useful, or applying a shortcut in every question again may not be useful. Okay, so I think more than the technique, you got to understand how to apply and where to apply. Okay, so let's get started. I'm sure all of you are ready to learn this very interesting technique that I'm referring to, and this is called the digital route method for simplification. Now some of you must be aware of this method already, right? Those who have enrolled in TalentSprint program, I'm sure definitely know about this because this has been covered in our videos, right? But for those who are unaware, let's quickly discuss, and I'm sure even for those who are aware, it will be a kind of a refresher with some practice. Okay, so what we are going to discuss today is called the digital route method, right? Now you must have heard about the unit digit method, right? Unit digit method can be used to solve questions from simplifications. It cannot be applied in approximations, but definitely in simplifications. So like unit digit method, there's something called as digital route method, right? So our discussion today will be on this whole idea of digital route method, right? So first of all, let us understand what is digital route, right? And then we'll look at the application. Okay, now what is digital route? Digital route, it is also referred to as root digit, but then let's stick to one terminology, right? Digital route. What is digital route? A digital route basically is a process where you find out, you keep summing the digits of a number till you arrive at a single digit number. In simple words, it's like, it is actually popularly called as the lucky number, right? I mean, people who believe in numerology, they have this whole idea of a lucky number, right? Or a favorable number. Like let's say somebody has a lucky number 5, right? I mean, he believes that the lucky number is 5. So he would want, or he or she would want everything around him or related to him to be, summing up to 5. Like, these people usually like their, the vehicle numbers to add up to that single digit 5, or their phone numbers to add up their single digit 5, or some people in fact go to the extent of having bank account numbers where the digits all add up to 5 and that probably brings them wealth. I mean, that's the theory anyway, right? 5 or whatever the number is. So I'm sure you understand what I'm referring to, right? Lucky digit, lucky number, right? Now, how do we get this lucky number? It's about adding up the digits of the given number, whatever be the number, right? It could be your bank account number or your vehicle number or your phone number or your date of birth to arrive at that single digit. Of course, date of birth is not in your control, but then, you know, the point is that you add up the digits of a number till you arrive at a single digit, right? You keep summing up the digits till you get a single digit number. Now that's called a digital root, right? That is called a digital root. For example, the digital root for today's date, right? Now what is the date today? 14th Feb 2018, right? Now find out the digital root, 14th Feb 2018. So 14022018. So what do? Add all the digits. You may get a single digit number in the first step itself. Even if you don't get a single digit number, you repeat the process with the new number till you get a single digit number, right? So 14022018. So 1 plus 4, 5, 5 plus 0, 5, plus 2, 7, plus 2 again 9, plus 0, 9, plus 1, 10, plus 8, 18. Now you've got 18. When you add up all the digits, you get 18. 18 again is a 2-digit number, right? We are looking at a single digit number. So 1 plus 8. You know, repeat the process. Now the number you have in hand is 18. 1 plus 8, 9. So the digital root for today's date, I can say, is 9. Likewise, you can find out the digital root for your own, you know, date of your own birth and things like that. So this is the whole idea. Now, what's so special about this digital root and what's the application? Let's look at it. So I'll first take up a few examples to help you understand how to calculate digital root. While we have already understood, it's simply summing up the digits till you get a single digit number. But then there is a technique which can help you find out digital roots really fast, right? And then we will look at the application. So let me share my screen and take up an example to help you with this, right? So we are talking about digital root. Right, so let's understand what is digital root in the first place, right? So I have explained you, it's the sum of the digits of a number, right? So today's date, like we have taken 14 Feb 2018. What do we do? 1 plus 4 plus 0 plus 2 plus 2 plus 0 plus 1 plus 8. Yeah, so 1 plus 4 is 5 plus 0, 5 plus 2, 7 plus 2, 9 plus 0, 9 plus 1, 10 plus 1, 18. 18 again. This becomes 1 plus 8, which makes it 9. So the digital root for date today is 9, right? It's 9. Likewise, any other number, right? I mean, it could be any number. Let's say your, you know, your roll number for SBI Clerk's examination, which you are going to appear for. Let's take some 7-8 digit number, right? So 1 2 7 3 6 8 5 2 4 3 9. Let's say that's your roll number. Now find out the digital root for this one. This is one example that we have taken. Let's take another example, right? Digital root. So what do? Keep adding the digits. Now add the digits. 1 plus 2, 7, 7 plus 7, 14, 14 plus 3, 14 plus 3 is 17 plus 6, 23 plus 8, 31 plus 5, 36 plus 2, 38 plus 4, 42 plus 3, 45 plus 9, 54. Okay, I'm getting 9 again. So let me just change it a little bit. I'll make it, let's say, yeah. Let me just repeat the process. So 1 plus 2, 3 plus 7, 10 plus 3, 13 plus 6, 19 plus 8, 27 plus 5, 32 plus 2, 34 plus 4, 38 plus 3, 41 plus, oh, hold on. I was better off with the previous number itself, but yeah. 54, 56. So we have got 56, right? 56. 56. Again, this is 5 plus 6. 5 plus 6 gives me 11. But again, I am looking for a single digit number. So go to the next step. 1 plus 1, 2. So the digital root for this is 2. The digital root for this number is 2, right? Similarly, let's say what's the digital root for 13? The number 13. What is it? Simple. 1 plus 3 is 4. So the digital root here is 4. You're getting it? So basically, whatever be the format of the number, is it your, you know, date of your birth or some roll number or any number there, the digital root is sum of the digits. Let me just take the second one. I am not sure if I'm doing the right calculation there. Quickly, let's verify. So 3, 10, 13, 19, 27, 32, 34, 38, 41, 50 and 56. I think, yeah, 56. So it gives us 2. All right. So this is how you find out the digital root of a number. Digital root of a number. Now let us understand what is the significance of this digital root. What does it mean? All right. I mean, what do you understand when I say digital root of 13 is 4? Digital root of 13 is 4. What does it mean? What does it mean? See, now I mean, I don't want to get into the details here. You can refer to our videos for the detailed understanding of this. But the point is, you know, when I say digital root of 13 is 4, we are actually trying to say that 13 is 4 ahead of 9. You understand? See, 9 is a very powerful digit. Basically, this whole concept revolves around 9, right? I mean, the concept of digital root revolves around 9. So, if you look at 11, let's take an example of 11, right? What is 11? Digital root for 11. 11's digital root will be 1 plus 1, 2. Now, if you observe, 11 is 2 more than 9. 11 is 2 more than 9. If I take 13, what is the digital root of 13? Digital root of 13 is 4. So, now 13 is 4 more than 9. You understand? So this is relative to 9. The digital root actually gives you a relative position with respect to 9 or a multiple of 9. With respect to 9 or a multiple of 9. Like for example, we took this second case, right, where we had taken a long number, right? 1, 2, 7, 3, 6, 8, 5, 2, 4 and so on. What did we get? We got the digital root as 2. Now does it mean that that number is only 2 more than 9? No. But this number is 2 more than a multiple of 9. This number is 2 more than a multiple of 9. You are able to follow. For example, let me take up 24. Tell me what is the digital root of 24? The digital root of 24 will be 6. 2 plus 4 is 6. Now, can I say that 24 is 6 more than 9? No. But 24 is 6 more than a multiple of 9. See, 18 is a multiple of 9. 18 plus 6 gives us 24. Right? So, digital root actually gives you the relative position of that number with respect to a multiple of 9. Right? With respect to a multiple of 9. Now, well, that's not really very useful to us in the exam, right? I mean, how do we actually use it? There are certain laws related to digital root. Now, those laws will be helpful in solving some questions. Before I explain those laws to you, let me mention something very, very important. I would still repeat that this is not the best of the ways to solve questions. I am explaining this to you so that you must be aware of all such techniques, right? Out of 10 questions that you solve under simplifications, maybe one question will be such where applying digital root is the best thing to do, right? It's not always the best thing to do, right? Unidigit method definitely is better than digital root method if it is applicable. Approximation definitely is better than digital root method if it is applicable. Yeah, only when you know, these other methods fail, unidigit method, approximation method, or you know, regular method is taking too much of time, then you should go for the concept of digital root. Okay, so let me explain you how to use digital root, but before that let me also explain how to find out the digital root of a number very quickly. Like when we took that you know, really large number, some of you commented that this is what happens to us in the exam, right? We get confused as to we have calculated the right value or not. So let me make it simple, right? Let me tell you how to calculate the digital root very quick. Now I've already told you that 9 has got some importance here. Now the concept here is, whenever you're finding out the digital root of a number, you can always skip 9s in the number there. Either 9 or numbers that make up 9. Like for example, look at the first number, right? 14022018. Is there any value that is 9 here? No, there is no number 9. We know that the digital root itself is 9, but in the given value 14022018, there is not a single digit which is 9. However, 1 and 8 make up 9, right? 1 plus 8 is 9. So you can forget about 1 and 8. You're able to follow. 9 will not change your digital root. Any number of 9s that you add or subtract from the number, it will not change your digital root. So you can forget about 1 and 8. If remaining number is also making 9, you can forget about it, right? But then we don't find anything else which is quickly making up 9. Of course, 1 plus 4, 5, 5 plus 2, 7, 7 plus 2, 9. So this also can be excluded. So actually we have nothing left, and nothing here means 9. The digital root is 9. Yeah. For example, let's say, let me take up another example. We are finding out the digital root of 3, 7, 5, 2, 4, 6, 1, 8, 9, 5. I have to find out the digital root. Do I have to add all the digits? No, because 9 itself can be eliminated here. 1 and 8 is equal to 9. 1 plus 8 is 9, so forget about it. 7 and 2, 7 plus 2 is 9, forget about it. 5 plus 4 is 9, forget about it. 3 plus 6 is 9, forget about it. What is left out? 5. So digital root directly here can be taken as 5. Look at the second example, right? We struggled so much in adding up all the digits. Instead, forget about all the 9s. So 2 and 7, 3 and 6, 8 and 1, 5 and 4, 9. Anything else that is 9 there? No. Or yeah, 3 plus 4, 7, 7 plus 2 is 9. What is left out? 2 is left out. Digital root is 2. I don't have to do all this drama in between, right? So the point I'm trying to make is when you're calculating digital root, you can always skip 9 or digits which are making up 9. It can be 2 digits or 3 digits. If it is adding up to 9, you can just exclude those in your calculation. Obviously, it becomes easier. I mean, when you know that certain digits are not to be added at all, it becomes easier. 9 is like 0 there. 9 doesn't really affect or impact your answer. Okay. So what we have learned so far is what is digital root, how to calculate digital root, and what is the significance of digital root. Like it gives you a relative position with respect to multiple of 9. But then what is the application? What is the application? The application in simple words is as follows. The digital root of the sum of two numbers A and B is equal to the digital root of A plus the digital root of B. The digital root of product of two numbers A and B is equal to the digital root of A into the digital root of B. The digital root of difference of two numbers A and B, A minus B, is equal to the digital root of A minus digital root of B. Now you make it a negative number. If it is a negative number, you have to add 9 to it to balance it out, right? Remember, digital root in maximum can be 9. It cannot be more than 9. You understand? It cannot be more than 9. Digital root maximum can be 9 because we are trying to obtain a single digit number. Can it be more than 9? No, it's not possible that it's more than 9. So in case if you are trying to find out a digital root somewhere, if you get a negative answer, I mean for a positive number, you'll always get a positive digital root. But when you get a negative number and you want to find the digital root of that, what do? Forget about negative sign, get the digital root and then subtract that from 9. You know, that's how it works. I mean, these are all details. As we solve more and more questions, you'll be able to figure out. Now, let me explain some questions to you. Simple questions. Let's start with simple questions and then look at the application. Okay. So, point is, if I'm adding two numbers A and B, see A plus B is equal to what? Let's say the simplification question that you have in the exam is A plus B is equal to what? A plus B is equal to what? A plus B is equal to what? What do? If you want to go by digital root, right? The digital root of A plus the digital root of B should be equal to the digital root of A plus B. You're getting it? Digital root of A plus the digital root of B is equal to the digital root of A plus B. Now, if you keep this in mind, calculation becomes easy, right? The question says A plus B is equal to what? I'll find out the digital root of A. I'll find out the digital root of B. I'll add these two to get a digital root. Now, this should be equal to the digital root of the answer. Options are given to you. Find out the digital root of all the options. The one that matches with the given digital root that you have obtained in the question is your answer. Now, there is a catch here. What is the catch? If multiple options have got the same digital root, then this technique will fail. You understand? It's like unit digit method, right? Unit digit method is very, very simple, very easy to apply. But it works only if all the unit spaces are different. If options are having different unit spaces. If options have the same unit space, then there's no point in applying the unit digit method. Similarly, if all the options are ending with the, all the options are resulting in the same digital root, then you cannot really apply this method because it fails. You will not be able to decide what the correct answer is. Okay, so let's look at some examples to understand this. I'll take up some simpler questions before we look at a real question type that can be asked in the exam, right? So let's say we have to find out 237 plus 496 is equal to what? I'm just taking a very simple example. Don't expect that such questions will be asked in the exam, right? Absolutely not. This is a sitter. Okay. So 237 plus 496 is equal to what? Now find out the sum. Find out the sum first of all. 237 plus 496. What will be the answer? 600, or maybe I can take it as 500. 500 plus 237 is 737 minus 4, 733. The answer is 733. Yes or no? 237 plus 496 is equal to 733. 600 plus 120, 720, 720 plus 13, 733. Right? Now, how can we apply digital root? Simple. The law says that digital root of this number plus the digital root of this number should be equal to the digital root of this number. Yeah, so let's try it out. What is the digital root of 237? Find out. See, 2 and 7 is 9, right? So digital root here is 3. 496, 9 is eliminated. 4 plus 6 is 10. 10 is nothing but 1. Digital root of 10 is 1. Yeah. So the digital root of this number is 1. So what is the overall digital root on the left hand side? 3 plus 1. Digital root of 3 plus 1. 3 plus 1 is 4. Digital root of 3 plus 1 is, 4. So the overall result on the left hand side gives us a digital root of 4. The law says that the digital root on both the sides should be equal. So if this is 4, this also should be 4. Look at the answer. 733, right? What is the digital root of 733? See, 3 plus 3, 6. 6 plus 7, 13. 1 plus 3, 4. Digital root here is also equal to 4. Are these equal or not? Yes, they are equal. I hope all of you have understood. The application. How can we apply this? So if suppose this is the question with options. This is the question given to us and multiple options are given. I'll find out the digital root of the question. I'll find out the digital root in each of the options and check which one matches. The one which matches is the answer there. It works for multiplication as well. It works for subtraction as well, right? Like for example, let's say we have 38 multiplied by, just taking a simple example, 38 multiplied by, let's say 52. Find out the answer. 38 into 52. What is 38 into 52? I think 45 minus 7, 45 plus 7, right? So 2025 minus 49. It will be 1976 in my view, right? Check this quickly. 38 into 52. 45 plus 7, 45 minus 7. 2025 minus 49. So 1976. Yeah? 1976. Or there are different ways of doing it. 52 into 40 will be 2080 minus 104. 1976. Right? Now check the digital root. Is it applicable or not? I mean, is it possible or not? Digital root for 3 it will be 2. Digital root for 7 and 552 is 7. Now multiply these two. See, here we have added, but here you have to multiply because the operand in between is multiplication. Operator is, into, right? Now 2 into 7 is 14. 2 into 7 is 14. Digital root of 14 is 5. Check the digital root for this number. 9 anyway gets eliminated. If I give 2 to 7, this also becomes 9. You understand? There's one more technique in finding out digital root. It can be made even more simpler. I don't have to add 1 plus 7 plus 6. From 6, I will give 2 to 7. 2 and 7 becomes 9. So forget about this. What is left out? 4. 1 plus 4 is 5. I mean, even otherwise for 1976, the digital root is what? 1 plus 7, 8. 8 plus 6, 14. 14 again will give you 5. That's fine. But the technique is, what I can do, I can give 1 to 7. So this becomes 8. I can give 1 from 6 also to 7. This becomes 9. So 9 and 9 gets cancelled. Finally left out is 5. You understand? So 5 is the digital root. Balanced or not? It is balanced. It is equal. Are you getting it? So this is how digital root can be applied, right? It can be applied in the exam. Now you will not be getting such simple question in the exam, but yeah, let's take up a couple of examples. I mean, we don't have enough time to try out more and more examples here, but I'm sure you will do it yourself. Let's take some examples to understand this. Now there are certain limitations here, by the way. See, it works for subtraction as well. Let me explain you subtraction before we proceed. How does it work on subtraction? Let's say we have 963 minus 842. It works. What is 963 minus 842? 121. 121, right? What is the digital root for 963? It will be 9, because 9 and 9. I mean, everything gets cancelled means the digital root is 9. What is the digital root for 842? I can give 1 to 8, it becomes 9. So 4 and 1, 5. This is 5. Digital root of 9 difference 5 is 4. Digital root of 9 difference 5 is 4. 9 minus 5, 4. What is the digital root of 121? It is 4. Equal or not? Yes, equal. Understand, sometimes you may get a negative answer. Like for example, let's say if you have got the digital root as digital root is equal to minus 6 for whatever it is, or if you have got the differences, I mean, difference of these numbers is minus 4. What do? You have to take modulus of 9 here. So this is actually minus 6 plus 9. Add 9 to it, make it positive. Always add 9 to make it positive. Suppose you have got digital root of minus 4. So minus 4 plus 9, it can be taken as 5. Right? You've got, let's say, minus 8. Minus 8 plus 9. Digital root can be taken as 1. So a negative digital root means you have to just add 9 to it to balance it out. Okay. Now let me take up a few examples to explain this to you. Here's the first one. Here's the test, first one. So what will come in place of question mark? What will come in place of question mark in the following questions? Now, this is a simple question. I'm sure you don't have to worry about digital root to solve this. The question is 34 into 27 plus 63 into 70 plus 22 into 45 equals to what into 13 plus 10? Options are 526, 499, 508, 506, 501. Remember, like I said, suppose if I mean, it is not applicable always. The technique is not applicable always. In which cases will it fail? If the options have got same digital root. If the options have the same digital root, multiple options have same digital root, you will not be able to decide what is the correct answer. Or if fifth option is none of this. Suppose fifth option is none of this, then digital root technique cannot be applied. It is like unit digit method, right? Even unit digit method cannot be applied when the fifth option is none of this. Or approximations cannot be done when the fifth option is none of this. So that limitation is there. But keeping that aside, it's a wonderful technique. You should know where to use it. Now, if you think multiplying 34 with 27, 63 with 70, 28 with 45 is going to take time for you, and then subtracting 10, dividing by 13, all that is going to take time, apply digital root technique. You can try both the methods. I mean, you can apply unit digit method also. In fact, I mean, for this question, unit digit method also will work because only 2 options are ending in 6. Remaining options are with different unit digits. So unit digit method can be applied. You will be in trouble only if the answer is ending in 6. Yeah. You know what is unit digit method. I'm not getting into the details. Let's look at digital root method. Okay, so solve this now. What happens? See, 34 into 27 plus 63 into 70 plus 28 into 45 equals to what into 13 plus 10? Very quickly you have to find out the digital root. See, the advantage here, or actually now like I said, it can fail. It can fail in certain cases. Maybe in this case it will fail. But anyway, let's check what happens. See, try and understand one more concept is any number when multiplied by 9. Any number when multiplied by 9 or a digital root of 9 will always result in a digital root of 9. You don't have to worry about what that number is. Irrespective of what the value of n is, when the digital root, one of the other digital root is 9, the overall result will always be 9. Because you observe all the multiples of 9, 9, 18, 27, 36, 45, 54 and so on up to 72, 81, 90 or for that matter 189. All these are multiples of 9, right? All these multiples of 9 will always add up to 9 only. I am sure we have learned this in school days. Always it happens that 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 is 9 and so on. So the moment you take any so basically any multiple of 9 is gonna give you a result where the digital root will be 9. So if I look at it, see, this is 9, right? 63 is also 9, right? And so is 45. So I think the technique will be difficult because 34, whatever be the digital root, getting multiplied by 9, overall will result in 9 itself. This will result in 9 itself. See, 7 into 9, 63. 63 will give you 9. If you want to check the first one also. This is also 7, right? Digital root of 34 is 7. 7 into 9, 63. Digital root is 9. Here also the digital root is 9. Now, 2 plus 8. 2 and 8, the digital root is 1. 1 into 9, the digital root is 9. In between, we have sum. You're getting it? Bottommost rule. So, 9 plus 9 plus 9, 27. 27 again will result in a digital root of 9. So, overall, the digital root on the left hand side is 9. If the digital root on the left hand side is 9, the digital root on the right hand side should also be 9. Digital root on the right hand side will also be 9. Now, what is there on the right hand side? We have question mark multiplied by 13. 13's digital root is 4 and 10's digital root is 1. So basically, if I reframe the equation now, it is like this: 9 equals to question mark into 4 plus 1. All these are digital roots. So basically, I can say, see, 9 minus 1. You can take this 1 to the other side. 9 minus 1 is 8. 8 is equal to question mark into 4. Now don't divide. Never apply divisions in case of digital root, right? It doesn't work for divisions, right? Does not apply on doesn't work for division. So don't say question mark should be 8 by 4 2. Don't do that, right? You cannot apply digital root on divisions. So you cannot divide 8 by 4, but then substitute something in place of question mark such that the digital root will be 8. Overall digital root will be 8. Now it's obvious that the question mark's digital root should be 2. If you observe, see, this is 8. Only if this is 2, 2 into 4 will give you 8. Yes or no? Only if the question mark is 2, 2 into 4 gives you 8. If the digital root of the question mark is 2, then 2 multiplied by 4 give you 8. So I am sure that the question mark's digital root should be 2. You're sure that the question mark's digital root has to be 2. That's it. And what is he asking us to find out? He's asking us to find out what comes in place of question mark. What comes in place of question mark? All these options. So check for which of the options the digital root is 2. That's your answer. Find out for each option the digital root is 2. that can be taken as a final answer, right? Now let's see. If only one option satisfies, you're lucky. If multiple options satisfy, then you are in a difficult situation, right? What we have understood so far is the question mark's digital root has to be 2. Now if I take option A, 526, what is the digital root? 7, 6, 13, this digital root is 4. Can this be the answer? No. 499, the digital root again is 4. Can this be the answer? No. 508, the digital root is 4 again. Can this be the answer? No. 506, 5 plus 6, 11, 11's digital root is 2. This is probably the right answer. Now again, just because the digital root is 2 does not mean option D is the answer. That should be the only option which has got digital root as 2. If option E is also giving you a digital root of 2, then this technique will not work. Now 501, what is the digital root? 6. Do we want 6? No, we want 2. So E is also not the answer. Hence the answer is option D, 506. Hence your answer finally is going to be 506, because I know that question mark should be equal to, should give you a digital root of 2. 506 is the only option that is giving digital root 2. Now in which case the technique will fail? For example, for the sake of example, let's assume that the digital root here is not 2, it is 4. Just for an example, that the question mark here should be such that the digital root is 4. In that case, this technique will fail, because first option's digital root is 4, second option's digital root is 4, third option's digital root is 4. Fourth option is 2, fifth option is 6. So in that case, option D and option E will get eliminated. But which of the first 3 options is correct? We don't know. We can't say. Which of the first 3 options will be correct? We can't really say. Right? So in this case, you will not be able to apply it. It is like unit-digit method, right? If 3 options are ending with the same unit place, can you apply unit-digit method? No, you cannot apply. Similarly, if 3 options are giving you the same digital root, then you cannot apply it. So it very clearly mentioned to you that digital root works not always. It works only, it has got its own constraints, right? Strings attached. So you should understand that thoroughly and then go for it. Right? You should then go for it. Some of you are confused that you've taken 9 equals to 0 and hence you got some other answer. 9 is equal to not 0. 0 is equal to 9. There is a difference. You understand? If you've got the digital root as 9, don't take it as 0. The understanding is if something is 0 means it can be taken as 9. Yeah? Don't try to deal with zeros when you're solving questions based on digital root. Okay? So I hope all of you have understood this. Lot of limitations. Option should have different digital roots. Option should have should not have none of this, and division should not be involved. It can be applied for division also in a smart way, not in a regular way. Like one digital root is 8, the other one is 2. You cannot say 8 by 2. The results digital root should be 4. That cannot be done. Yeah. So keeping all these limitations in mind, you have to practice certain questions. You definitely have to practice some questions, and I'm sure if you get the knack of it, you will apply it in the right place. Again, like I said, you should know where to apply. Just because it is interesting, don't apply everywhere. And don't go by the length of the explanation. It looks to be lengthy here because I've explained this to you in detail, right? I was not solving it for myself. When I have to solve it myself, I'll not put all these steps. I'll only look at the digital roots and, be done with it very easily. Of course, assuming options are giving you different digital roots there. All right, should we go for the next one? Should we go for another question? And I said, I know I've already mentioned this, digital root theoretically does not work for division, but smart students should know how to apply it. We have discussed about this in our video, so I'm sure you can refer to those videos to understand this. Let me take just one more question. Time is already up. Let me just take one more question to explain this to you, and then after that you can practice it yourself. Okay, so the next question is on your screens now. Look at this. What value should come in place of the question mark in the following question? So you have to find out what comes in place of question mark here. Again, just a simple addition subtraction based question. Remember, the big challenge that we have here is fifth option, none of this. So if you don't want to take any risk, don't solve this question using digital root. Then you have to do the regular stuff itself, right? The conventional method. But if you're ready to take a chance, or let's say you're solving this question in the last 10 seconds of your exam, and you know that this cannot be solved in 10 seconds conventionally, then maybe you can quickly try and find out the digital root. You're able to follow? A smarter approach will be to find out the digital root of the options first, and then you can decide whether you want to apply that or not. Yeah. So keeping fifth option, none of this out of it. See, you will be really lucky if the digital root of all the 4 options here, first 4 options here, do not satisfy the digital root of the question mark. Then definitely the answer is none of this. You're getting it? If going by digital route, you figure out that A, B, C, D cannot be the answers, then definitely option E is the answer. But if one of these options satisfies, then you will be in a difficult situation, because none of this is always possible. There's always a possible answer. So try and apply it. I'll leave you with this question for about 45 seconds. I know you can solve it regularly as well, but you this time have to try the digital route concept. Don't try to solve it in a regular way. Just use digital route concept and see what happens. Your clock starts now. Okay, the time is up. Let's look at the solution now. Now, like I've mentioned, the smarter approach here would be to find out the digital root of the options first, right? And that should be done really quick. I mean, you should not spend more than 5 seconds in finding out the digital root of all the options. Okay, so digital root of option 1. I mean, I'm for the sake of explanation, I'm doing all these cancellations and all. Otherwise, you can do mentally also. So 7, 9, and this gets cancelled. 7 plus 5, 12. So digital root is 3, right? Digital root of option B, 8, 8, and 2 gets cancelled. It will be 4. Option C, 6 and 3 gets cancelled, 8, 5, 13, so it is 4 again. Option D, 7, 2 gets cancelled, this will be 1. Option 5, of course, cannot be done anything. So digital roots are 3, 4, 4, 1. Now, for example, let's say if the question marks digital root comes out to be 5, definitely the answer is option 5, option E, none of this. Yes or no? If it comes out to be 6, definitely the answer is option E. If it comes out to be 7 or 9 or 8 or let's say 2, answer is none of this, because other options are not giving you that digital root. But if it comes out to be 4, there is a confusion. Option B and option C both are 4. If it comes out to be 3, even then there is a confusion, because option A is 3. That does not mean that option E is the answer. It could be option E also. You understand? See, the point is 797.52, right? And 797.25. Both will have the same digital root. Only the digits have been swapped. The positions have been swapped, right? The sum will not change. Sum of the digits will not change. So there is a constraint. There is definitely a constraint that answer, you may not be very sure about your answer if it is 3 or 1 or 4. But if it is anything else, then definitely option 5 is going to be the answer there. Okay. Now let's check for the question here. So quickly find out the digital roots. 4, 3, 2, 2. So I think it will be 2. 1, 2, 2, this will be 9. 549 will be 9. 27.5 will be 5. This will be 5 plus 2, 7. This will be 8. Forget about decimal. Don't worry about decimal and all that. I mean, that's the advantage. That's another advantage. You don't have to worry about there is decimal here, there's no decimal here. Irrespective of that, it is a sum of the digits. So what's the digital root that we have got overall? I'm just writing it here. You see, 2 minus 9 plus 9 plus 5 minus 7 minus question mark equals to 8. Yes or no? 2, 9, 9, 5, 7, 8. Take care of the signs. Minus, plus, plus, minus. Minus, plus, plus, minus, minus. And this 8. Now simplify. Minus 9 plus 9 gets cancelled. Right? Now look at this. Yes or no? 2. Here we have got 9. Here we have got 9. Here it is 5. Here it's going to be 7. And here it's... Oh, sorry, here it is 7. I'm sorry, on the right hand side is going to be 7. Sorry about this error. 1, 9, 9, 7, 8, right? So this 1 and 1 will get cancelled with 8 and we'll have 7. Sorry, this should be 7. It's going to be 7. Yeah. Now check, minus 9 plus 9 gets cancelled. 2 and 5 is 7. And this minus 7 gets cancelled. Yes or no? Now observe carefully. We got I'm sorry, my bad, I am not doing the calculation properly. The first one also is 7. This, I mean, 1,222 is also 7. I was multiplying 2 into 2 into 2, 8, and then I added 1. Sorry about that. Just a second. Yeah, let me just redo this. I think I'm in a hurry, and this is what happens when you're in a hurry. So you have to learn how to get over this. 1,222 is going to give you a digital root of 7, and this is going to give you a digital root of 8, right? Yeah. Just a second. Yeah, so let's now work on this. What happens? You've understood there was an error here. 1,222 error from my side, sorry. 7, this is 957, and this definitely is going to be this definitely is going to be 8, right? This 1 and 1 and 7 will make it 9 and 9, and then we're left with 8. Now find out what happens. So yeah, so 2 plus 9, 11. I'm adding all positive values, right? 2 and 9, 11. 11 plus 5. 11 plus 5 is 16. 16 minus 14 is 2. 16 minus 14 is 2. You understand? 2 minus 7 minus 5. Minus 5 plus 9, 4. 4 plus 5, 9. 9 minus 7 is 2. So 2 minus question mark is equal to 8. Which implies question mark is equal to what? Understand. Question mark will be 2 minus 8. It gives you minus 6. But digital root cannot be minus 6. You have to take modulus of 9 for this one, right? So minus 6 will become minus 6 plus 9. Add 9 to this one, right? It cannot be minus 6. It should be minus 6 plus 9. So minus 6 plus 9 is how much? 3. So I know that the digital root of question mark should be equal to 3. Now because the digital root has to be 3, you can see that option A satisfies. Option B 4, not possible. Option C 4, not possible. Option D 1, not possible. It should either be option A or option E. And now you have no choice. Either you go for option A, go by your gut, or if you don't want to take any chance, then do the complete calculation. But then if you are not ready to take any chance, and eventually if you have to do complete calculation, you were better off doing it in the beginning itself. See, solving the same question in a regular method also is not going to be very complex, right? It will take about 45 seconds for you to do the whole calculation, right? You're able to follow. So my point is, in such situations, these kind of situations will be very common in the exam, right? So if you come across such a situation, make up your mind in the beginning itself. Are you ready to take that chance? If you were ready to take the chance, you have to mark option A as the answer. If you say no, I don't want to take any chance, then you better do the regular method itself. Then digital root is not the best thing to apply. Okay. Anyway, the answer to this question also is option A itself, 797.52. So I hope all of you have understood the point here, right? Practice is going to be the key. After this, you have understood the concept. There are a lot of other things that can be learned here, right? I mean, learned around digital root, like how do you use it for divisions, how do you use it for squares, right? How do you use it for percentages? And if you observe, the two questions that we have solved today are all addition subtraction based one, but if multiplications and divisions are involved, then what do you do, right? But I think we don't have enough time for that. I am constrained with the time here, so I would like to close it here. I wish I could do more, but never mind. I'm sure you will practice yourself and learn all the techniques. Of course, you have videos of TalentSprint that you can check out and learn this in detail, right? But for that, you'll have to look at our program. So if you are looking for a platform to get ready for your SBI Clerks exam, don't forget to check out talentsprint.com/bank before you take a decision. Okay, I'm not here to prescribe that you should join TalentSprint, but you should join some coaching, because that will give you a right path, right? And it will give you that strategy and approach with which you can complete your preparation and walk into the examination center with confidence. Okay, on that note, let me close it here. Remember, knowing the technique alone is not gonna be enough. Practice is really very, very important. So keep practicing and take very good care of yourselves. I'll see you all in the next session, the next score booster, tomorrow at